This is section 4.2. We're going to look at properties of isosceles triangles. We'll start with a warm-up. This combines stuff that we learned yesterday and from the previous chapters. We have two parallel lines, and then we have a transversal, and then we want to figure out angles x and y. So first I'd start in the triangle. You should know there's 180 degrees in a triangle. So to get this missing angle right here, so first we're going to start with this missing angle. So to find this angle, we're going to take 180 minus 90 minus 40. So that'll give us 50 degrees. All right, we know vertical angles are congruent, so this is 50 degrees. We know a straight line, there's 180 degrees. So 180 minus 50 is 130. So this angle is 130 and this is 130. Next, we know we have parallel lines, so there's a couple special properties with these angles. We know alternate interior angles are congruent, so this is 50, this is 50. This is also 50. And if this is 50, this must be 130. Also, they're corresponding, so you could figure it out that way, or they make a straight line. So x is 50 degrees, y is 130. Today we're going to look at properties of isosceles triangles. We already know a couple things about isosceles triangles. In an isosceles triangles, we have two congruent sides. So they should be marked. So let's say these sides are congruent, these sides are congruent. The angle where the two congruent sides meet, this is called your vertex angle. Again, this is where the two congruent sides meet. The other two angles are called the base angles. That's where your congruent side meets your non-congruent side. Base does not always mean bottom. If you look in this picture right here, these are your base angles. And here the vertex angle where the two congruent sides meet. It's right here. This is the vertex angle. So base doesn't mean bottom, it just means where the congruent side meets the non-congruent side. So there's the vertex angle and base angles. We're going to do an investigation in class with patty paper. We're going to draw an angle, we're going to fold it so it matches onto itself. Copy that point, unfold it, and call that point B right here. So we did that. Explain how we know it's isosceles. Well, we folded it on top of itself, so we know this is a mirror image of this right here. The next step, once we make our isosceles triangle, is use the protractor to compare the measures of the base angles. What do you notice about the relationship? So we're going to measure this angle and this angle right here, and we should notice that those are congruent. And this should be noticed in all of the isosceles triangles that you have in your group. So the next conjecture right here is if a triangle is isosceles, then the base angles are congruent. And the converse is also true, so we've discussed converse. In an if-then statement, we have if a triangle is isosceles, then the base angles are congruent. The converse is when you switch the order. So we have the if and the then stays in the same order. But we'll switch the order, so we write if the base angles are congruent. Then the triangle is isosceles. And that's the converse, and this is also true. So we're going to apply these two conjectures, two problems in your assignment. Here's some examples. Find the missing measures. Well, we know this is isosceles because two sides are the same. So from the conjecture, if the triangle is isosceles, the base angles are congruent, so this is also 58 degrees. Again, we have an isosceles triangle, so it means this angle is the same as this angle. We know there's 180 degrees in a triangle, so we're going to subtract the 90, and then we'll divide by 2. So 180 minus 90 is 90. Divided by 2 is 45. So this is 45 degrees. And for number 3, again, it's isosceles, so this angle is the same as this angle. So I'm going to find this angle first. We know this is a straight line, so we have 180 minus 110. So this is 70 degrees. To find these angles, we're going to take 180 minus 70, divide by 2. So that again is 110 divided by 2. So each of these angles is 55 degrees. Then to get angle x, it makes a straight line with the 55. So angle x is going to be 180 minus 55. So that'll give us 125 degrees. So here we used a couple different properties. Straight lines, triangles, straight line. Number 4, the measure of angle A is blank. The perimeter of triangle ABC is blank. So we have to figure out first what this measure is. We want to see if it's the same as 39. So 180 minus 102 minus 39, what does that equal? It equals 39. All right, so this is isosceles because the base angles are the same. So if it's isosceles, it means this side is the same as this side. So if this side is 13, this side is also 13. If A is 13, we're going to plug in for this side, do 13 plus 7, and we get 20. So the perimeter is going to be 20 plus 13 plus 13, which will give us 46 centimeters. And angle A is 39 degrees. Here the perimeter of LMO is 536. LM equals blank, and the measure of angle M equals blank. Excuse me. So let's figure out this angle, or this side first. So we know the perimeter is 536. We're going to subtract 210 and 163. And we're going to find that this is also 163. So this is isosceles. It means this angle is the same as this angle. So I'm going to call this x. So to find the degrees, there's 180 degrees in a triangle. So we have 180 equals, count your x's. We have 3 x's plus 30. We're going to solve. So we're going to subtract 30 from each side first. We get 150 equals 3x. Divide by 3. So here x equals 50 degrees. So the measure of angle M is 50 degrees, and the side LM is 163 meters. So here are a couple examples using the properties of isosceles triangles plus other properties that we've learned previously. So the assignment is right here.